Let's look at a real world problem. This says that the area of a rectangle is 40 inches squared, and we want to find what x is. So we know that the area of a rectangle, A, is equal to length times width, or you might have learned it as base times height, either way. We know that the area itself is 40, that was given in the problem, and my length and width are given in terms of x. I have an x and an x plus 3. So I want to solve this equation. 40 is equal to x squared plus 3x, and I want to go ahead and move the 40 to the other side so that I have a 0 on one side or the other. X squared plus 3x minus 40. Now I can turn that around and say that the 0 is on the other side just to kind of set it up in the form that I'm typically used to having. I didn't want to move the x squared over to the other side and have a negative x squared, because then all of a sudden my a value is a -1 instead of a 1, and I would have to deal with that. So this one, my a value is 1 in front of that x squared. So I'm able to go straight to factoring. And I'm going to come up with x in the front, a +8, and a -5. I need two factors that multiply to be a -40, but add to be a +3. Using the zero product property, I have x plus 8 is equal to 0, or x minus 5 is equal to 0, leaving me with x equals -8, or x is equal to 5. Now, let's think about this. This is a real world problem now, and if I have x equal -8, that's going to mean a length of negative numbers, and distance or length can't ever be negative, so we want to go ahead and say that this can't be a solution because distance can't be negative. So whenever you're dealing with a real world problem, you have to put yourself in a real world situation. Time can't be negative, distance can't be negative, those sort of things.